Hello, I'm back again, and this time I'm going to be talking about 1.3.3 networks in the computer science, obviously. Oh my gosh, there's a lot of this. A protocol. It's a set of rules to govern data transmissions across a network. Examples of protocols include TCP/IP, POP, and FTP. This allows networks to communicate by ensuring all devices follow the same rules. This means devices interpret data in the same way. Whew. Standard, an agreed way of doing things. Standard makes it easier for people to build programs and software that work on different systems in different countries. Examples include MP3, HTML, and the USB. I know a few more, but that's all I'm going to say because that's all I can remember. A domain name system, a DNS, is used to find the IP address of a site using URL. A domain entered and sent to the DNS server, like www.google.co.uk. That's all. DNS servers map this domain to an IP address by looking up in a look up table. That is a bit questionable, but I suppose it must be right. If the DNS server cannot find it, it passes the request on to another DNS server until it is found. A bit like can a camera? Oh, can you see a trash can or a bin? Can you see a bin anywhere? First camera? No. Second camera? No. Third camera? I can see a bin, and it's got Ben's face on it. Where am I? I'm now. The origin. Oh, when the IP address is found, it updates all the DNS servers that didn't know about it. The origin of the DNS server sends the IP address to browsers so it can retrieve the website from the server on which it was hosted. The IP address that uniquely identifies a device on a network. An IP address is a logical identifier. The TCP/IP stack. Various protocols operate at each layer of a stack, each with different roles. The application layer sits at the top of the stack. If a browser is used, then it uses the HTTP protocols. Then there's transport, yeah. It uses the transmission control protocols, TCP, to establish the end-to-end connection. It splits data into packets and then adds the packet number, the total, and the port, and just sends it on its merry way through the internet. The routers operate on the network layer, adds the IP address to the packet to and from, and the link adds the unique media access control, MAC, McDonald's, and adds that address here, and the source and the destination of the MAC address is added. Off it goes onto the internet. I think. Please say yes. Okay. We've also got the local area network, a group of devices over a small geographical area. The equipment is owned by the network owner, and the range could include a building or a canvas, a bit like Hudson College. A WAN, wide area network, a group of devices connected over a large geographical area, often uses third-party communication channels, and range could include the entire world. Like that internet question that I just did. Okay, circuit switching creates a direct link between two devices for the duration of the communication. Oh, I do like this one. The public telephone system is an example of circuit switching network. The connection is set up for the entire duration of the message, including periods of silences and like pauses. Or maybe like a butt dial. They're funny, aren't they? Bandwidth is wasted during the periods where there is no data being sent, because it can't just tell that there's no data being sent. But the two devices must transmit and receive data at the same rate. Since it's an exclusive connection between two devices for the duration of the communication, the data packets arrive in the same order as they were sent, simplifying the process of reconstructing the message at the recipient's end. That was a bit hard to say, but I managed to do it. The packet switching. Data is split into equal-sized packets. Each packet has a header of information, including destination, address, and the place of the packet in the complete message. Each packet is placed on the message. Each may travel by different routes, meaning that they may arrive at the different times. At each node on the network, the destination address is read and the best route is found. So if you're in the middle of a highway and going, I could stay on the highway and get there easier, because the sat-nav does say that. But then if I turn off at this road, go left, go right, go forward, go straight, go left, then that's actually quite a bit easier, since there's a massive traffic jam because someone's been run over or something. No, that seems a bit evil. Next one though, the packets need to be recorded at the destination. That's true, so if there's not enough packets, then it'll send another bit out. Oh, and the benefits to this, apparently. Transmission is safer from interception because it is impossible to intercept all the packets as they're taking different routes. It's very efficient use of networks as it does not tie up a part of the network, and if there is an error, there will only be a small identificationable. I can't say that word. If there's an error in a bit of it, a small piece of data will be affected, and it can easily be retransmitted. But if you just don't have one piece, then you can just bam, send it along, send it backwards to the place. And where are we now? Oh, unauthorized access. Access to a computer system by users who have not been authorized to access. This could be users with correct usernames and passwords who are not who they say they are. And a firewall. A firewall is a hardware device or a piece of software. It monitors traffic going in and out of a network. Why do we use a firewall? Well, it's to prevent unauthorized access to a network, to restrict applications that are used internally to have some internet access. I don't even know what that means. To restrict websites that can't be accessed from within the company, and to protect the company's data. Hackers, them flipping hackers, they're a person who gains unauthorized access to a system or network in order to commit a crime, which is evil. A hacker may, for example, steal information to hurt people via their identity theft, or damage or bring down systems, or often hold the systems hostage for ransom. I mean ransomware. Oh, I haven't actually finished on other things ever. A proxy server intercepts all package entering and leaving a network, hiding the true network address of the source, enables privacy and anonymous surfing, can maintain a cache of websites commonly visited, saving resources from multiple requests, often used to filter requests, providing administrative control over content that user demands. Network, a collection of two or more computers connecting to each other in order to exchange information and share resources. Ta-da! Why use one of these networks? Well, there are 6 points, I think it is, and that they are file and data sharing, thumbs up, resource sharing, which is printers, and ETCs, which is etceteras, like tape recorders, because that's another one. Data protection and redundancy, the ease of administration, distribution of computing power, and internet communications. Everybody clap there. Everybody clap at me. It's so hard to speak though. I'm like 3/5 done in this bit and it's already 10 minutes in it. Network threats though. Things which could threaten a network. I could have guessed that. These risks are all needed to migrate to using the appropriate tools. Whew. Phishing. The fraudulent practice of sending emails claiming to be a trustworthy company in order to induce individuals to reveal personal information, such as passwords and credit card numbers. That's kind of bad. Distribution denial of service attacks, DDoS. Any type of attack where an attacker attempts to prevent legitimate users from accessing the server. In a DOS attack, the attacker usually sends excessive messages asking the network or service to authenticate requests that have invalid return addresses. This attack can make use of botnets, like that game. What's that game that I played? Whether you need bonnets to require things. I always got so confused. Oh my gosh, why are you talking about a game? Bonnets is a collection of devices injected with a malicious piece of code. The SQL injection, which is the next one, when malicious SQL statements are added onto the end of legitimate code. This can be done using fields on a farm and could be used to delete or extract data. I'm still not sure what fields on a farm might mean. Alright, phishing. I like this one because it's fishing but with a PH instead of an F. Like farming. Oh, wait, I've done fishing already. Farming, which is a PH instead of an F. The fraudulent practice of directing internet users to a bogus website that mimics the appearance of a legitimate one in order to obtain personal information such as passwords, account numbers, and ETCs, which means etc's. Or virus. A virus is bad. Viruses can self-replicate, but they rely on other host files to be opened in order to spread themselves. They can be protected against using an up-to-date virus scanner. That must be something like important. I wonder if I have a virus scanner. I'm not a dodgy person though. Spyware. Software that enables the user to obtain covert information about another's computer's activities by transmitting data covertly from their hard drive. Can be protected against using an up-to-date anti-spyware program. That sounds a bit weird, to be honest. What are you doing? Oh, I've just been looking at Ben's computer. He's searching up Pokemon videos and how to do things on Minecraft. Client servers. Controlled by a central server. Central administrators in one location, including S/W updates and security patches. One location to back up the files. File servers. Has a central point of failure. Bracket servers. Can be expensive to maintain and set up. Cable costs. Specialist staff. I don't know if you realise that the bracket servers, if it fails in one place, it will be one place and that will be the server. Oh, the peer-to-peer. The P2P. The P2P has no central server. Devices on the network have equal status. Multiple locations to back up. Has no central point of failure. And cheap to set up and run. And devices share data. My teacher actually told me about this, and I thought it was pretty sweet. It's a bit complicated, you know. It's weird. That's what it is. It's like, oh, Ben's streaming. What's the funny movie? Ben's streaming Rick and Morty on Netflix. Oh, but Ben's sister wants to watch it, but Ben's already 20 minutes in. Oh, good job, Ben's got the last 10 minutes, though she can watch it as well. Yep, we all just love Rick and Morty. I'm just staring at my Rick and Morty face mask right now. Because you know COVID. Where are we right now? This is the last part, I'm pretty sure. The modem converts between the digital data of a computer and the analog signals of a telephone line. The network cable requires to connect the components on a wired network. A router device that passes data between multiple computers networks via either wired or wireless connections. A server, a device which provides a central point of control. Network interface cards, NICs, a hardware component that allows a computer to connect to a network, may be useful for both wired and wireless connections. Wireless access point, a WAP, that sounds really funny. Device connection to the WAP all uses the same frequency and constantly tuned in, listening for signals. Uses a SSID, service set identifier, which is an identifier like the name of the wireless network. Not even sure if that's English right now. A switch, a device that connects devices together on a computer network by using packet switching to receive process forwards data to destination device. Switches are intelligent and will inspect the packages before sending them and the most efficient route. That's actually good because we've got to go on hubs. Hubs are stupid, but hubs are also inefficient as they do not inspect packages and they just broadcast the information out to every single device, and the device turns around and goes, oh no, the device decides if it's meant for the device, which basically means the device has the information and goes, is this for me? No, it isn't. And all the other devices will go, no, it isn't for me. And there'll be one person who'll be like, yep, that's for me. That's just clogged up my internet, but it's fine because I don't care. Okay, I think this is the end.